Hello children, welcome back to my channel. Now I am dealing with ninth class maths, quadrilaterals, and in quadrilaterals exercise 8.4 I am doing. The first one problem goes like this. ABC is a triangle in which D is a point on AB such that AD is equal to 1/4 of AB. So let me draw first a triangle ABC in which D is a point on AB in what is given. I'll write it here. Given in triangle ABC, AD is how much? 1/4 of AB. D is a point on AB such that AD is 1/4 of AB, and E is a point on AC. E is a point on AC such that AE is equal to 1/4 of AC. Now, what is our tip? We need to find out what is the measure of DE. For D, also they have given DE is equal to 2 centimeters. Now you need to find out what is our tip. We need to find out BC is equal to how much. What is the BC? That we need to find out. So here you do a construction. The construction is first one, join join DE. You have to join DE. Then locate a point X on AB and Y on AC such that AX is equal to XB and AY is equal to YC. That means, see children, here you are getting X and Y. Then you have to join XY. See, when AX is equal to XB, when AX is equal to XB and AY is equal to YC, XY are the midpoints of AB and AC. Similarly, when AD is 1/4 of AB, here in triangle, if you take in triangle, these are all our proof how the value will be getting, that we are going to do it here. It is actually not a proof, it is whatever we are doing the sum, calculating BC. We are finding out BC. How will you find out BC? See, in triangle AXY, now D and E are the midpoints of AX and AY. Why? Because this is what they have given, 1/4 of AB, and AD is AX is half of AB. AD 1/4 of AB, AX half of AB. That means definitely D and E are the midpoints. Now in this case, what we can say, if they are the midpoints, basing on the theorem, DE is parallel to XY and DE is half of XY, basing on the theorem which we have learnt. That means what is XY? XY is equal to 2 times of DE. That is 2 into 2, that is 4 centimeters. XY measures 4 centimeters. And also XY is, or X and Y points. XY are the midpoints of X and Y. are the midpoints of AB and AC respectively. Therefore, what you can say, XY is parallel to BC and XY is half of BC basing on the theorem we have learned in the previous video. I have taught you children, if a line is drawn through the midpoints of two sides of a triangle, it is parallel to third side and also it is half of third side. So what is BC? BC is equal to 2 times of XY, that is 2 into what is xy we got, it is 4, that is 8 centimeters. Therefore BC is equal to 8 centimeters. This is the solution for this problem, children. Now once again, let me explain you. What did they say? There is a triangle ABC in which they have given AD is 1/4 of AB and AE is 1/4 of AC. And DE measure they have given as 2 centimeters. Now what is BC, that we need to prove. We need to find out what is required. I'll write it required to find RTF. I'll write required to find BC is how much. So here we need a construction. What is this? You have to join D and E. D and E you have to join. After joining D and E, you have to locate a point X on AB and Y on AC such that AX is equal to XB, AY is equal to YC. That means what? Uh, AY is equal to YC. That means what? You are locating midpoints of X and Y and join XY. Now, how we need to find out BC? First, you take triangle AXY. In this triangle AXY, D and E will be the midpoints. Why? Because AD is 1/4 of AB, AX is half of AB. So definitely D and E are the midpoints. If they are the midpoints, then we have learnt a theorem. Basing on the theorem, if midpoints of two sides of a triangle, the line joining midpoints of two sides of a triangle is parallel to third side and also it is half of the third side. So DE is parallel to XY and DE is half of XY. That means what is XY? 2 times of DE. They have given DE measure as 2 centimeters. So XY is 2 to the 4 centimeters. And also we know that X and Y are the midpoints of AB and AC and you are joining XY. So therefore XY is parallel to BC. XY is half of BC basing on the same property. So when they are like that, what is BC? 2 times of XY. We got XY as 4 centimeters. So BC is equal to 2 into 4, that is 8 centimeters. Please note it down, children. Now second problem, children. ABCD is a quadrilateral. EFGH are the midpoints of AB, BC, CD and DA respectively. Prove that EFGH is a parallelogram. So let me draw quadrilateral. A, B, C, D is a quadrilateral. Now, what else they have given? E, F, G, H are midpoints of E. See, AB midpoint is E, BC midpoint is F, DC midpoint is G, AD midpoint is H. So, you have to join this. You need to prove that EFGH is a parallelogram. What is given? ABCD is a quadrilateral. E is the midpoint of AB. F is the midpoint of BC. G is The midpoint of CDH is the midpoint of AD. What you need to prove, RTP? We have to prove that EFGH is a parallelogram. This we have to prove. There is a construction, children, here. What is the construction? You have to join AC and BD. Join AC and BD. Now let us go to the proof. Now in this proof, let us take triangle ABC. In triangle ABC, see, E is the midpoint of AB. This is given to us. E is the midpoint of AB. This is given to us. And then F is the midpoint of F is the midpoint of BC. This is also given to us. Therefore, we will say that EF is parallel to AC basing on the theorem. The theorem says if a line is drawn through midpoints of two sides of a triangle, it is parallel to third side of, and also EF is half of AC. EF is parallel to AC, EF is half of AC. Similarly, in triangle, let us take this triangle ACD, we get in the same way GH is parallel to AC and GH is half of AC. GH is parallel to AC, GH is half of AC. Therefore, in EFGH, EFGH, EF is parallel to EF is parallel to GH and EF is equal to GH. Why EF is equal to GH? Because EF is half of AC, GH also is half of AC. So they are equal in measure. Therefore, opposite sides are equal and parallel. This is the property of parallelogram only. Therefore, EFGH is a parallelogram. Hence, proved. This is the proof of this statement, children. Once again, what did they give? They have given a quadrilateral ABCD and E is the midpoint of AB, F is the midpoint of BC, G is the midpoint of CD, H is the midpoint of AD. Now we need to prove that EFGH is a parallelogram. For this, we need a construction. What is that? You have to join AC, you have to join BD. After joining that, let us take triangle ABC. In this triangle ABC, E is the midpoint of AB, F is the midpoint of BC. We have got a theorem in which if a line is drawn through midpoints of uh, two sides of a triangle, it is parallel to the third side and also it is half of the third side. So EF is parallel to AC, EF is half of AC. Similarly, if you talk about ACD triangle, definitely G and H are the midpoints of CD and AD respectively they have given. So again, GH will be parallel to AC, GH will be half of AC. That means what? In EFGH, EF is parallel to GH, EF is equal to GH. opposite sides are equal and opposite sides are parallel. So EFGH is a parallelogram. Please note it down. Now, for third problem, children, show that figure formed by joining the midpoints of rhombus is a rectangle. So, if you draw a rhombus, we know rhombus is a figure where all sides are equal and diagonals are perpendicular bisectors. So, figure formed by joining the midpoints. That means let us take EFGH. This point you call it, take it as E, F, G, H. These are the mid. Now, what is given? Let us see. A, B, C, D is a rhombus. E is the midpoint of AB. F is the midpoint of BC. F is the midpoint of BC. G is the midpoint of CD. H is the midpoint of AD. What is RTP? We need to prove that EFGH is a rectangle. If you want to prove EFGH is a rectangle, children, the property of rectangle is a parallelogram with one of its angle is 90 degrees is considered as a rectangle. So, if you could prove that EFGH is a parallelogram and one of these four angles is 90 degrees, then definitely you can say that it is a rectangle. So, let us go in that way. Construction. Construction is you have to join AC and BD. Of course, I have drawn broad line. Construction should be drawn in broken line, children. So, let me break this line. So, you have to join AC and BD. Now, when you join this, let us see, the proof is same as that of the previous one. Second problem. In triangle ABC, E is the midpoint of AB and F is the midpoint of BC. Therefore, EF is parallel to AC. EF is half of AC basing on the theorem. The line joining the midpoints of two sides of a triangle is parallel to third side and also it is half of third side. So basing on that, I have proved that EF is parallel to AC and EF is half of AC. Similarly, in triangle ACD, GH is parallel to AC, GH is half of AC. Therefore, in EFGH, opposite sides are parallel and equal. Opposite sides are parallel and equal. Therefore, what you can say? Therefore, EFGH is a parallelogram. So we have proved that EFGH is a parallelogram. We have proved. Now we need to prove one of the angles is 90 degrees. So let me take this point as P and this point as Q. I am getting a quadrilateral EPOQ. In quadrilateral EPOQ. Could you see, children? EPOQ. In this quadrilateral, see, EP is parallel to OQ. EP is parallel to OQ. Why EP is parallel to OQ? Because EF is parallel to AC. EP is a part of EF and OQ is a part of AC. So they are parallel. Similarly, OP is parallel to EQ. EQ is parallel to OP. See children, EQ is parallel to OP because EQ is a part of EH which is parallel to BD. So EQ is parallel to OP. Therefore, EPOQ is a parallelogram. When you could prove that this small quadrilateral is a parallelogram, then opposite angles are equal in parallelogram. Therefore, angle E is equal to angle O. What is angle O? Angle O is 90 degrees. Why? Because in rhombus, diagonals are perpendicular. So angle Y is 90 degrees means therefore angle E is also 90 degrees. So in parallelogram EFGH, angle E is equal to 90 degrees. Therefore EFGH is a rectangle. Hence proved. This is the proof of this problem, children. So let us go through it once again. What did they give? A, B, C, D is a rhombus. E is the midpoint of AB. F is the midpoint of BC. G is the midpoint of CD. H is the midpoint of AD. And they are asking us to prove that EFGH is a rectangle. So construction is you have to join AC and BD. When you join AC and BD, see, in triangle ABC, proof is just like that of the second problem. EF is parallel to AC. Why? Because E is the midpoint of AB, F is the midpoint of BC. So opposite, the EF is parallel to AC, EF is also half of AC. Similarly, in triangle ACD, GH is parallel to AC, GH is half of AC. So EFGH in this quadrilateral, opposite sides are equal and opposite sides are parallel. So EFGH is a parallelogram. We have proved. EFGH is a parallelogram. We have proved. Now we need to prove that one of these four angles is 90 degrees. So for that I have taken this point as P and this point as Q. Now EPOQ becomes a quadrilateral. In this EPOQ, EP is parallel to OQ because AC is parallel to EF. Similarly, QE is or EQ is parallel to OP. Opposite sides are parallel, so EPOQ is a parallelogram. If it is a parallelogram, opposite angles are equal. Angle E is equal to angle O. Angle O is 90 degrees. Why angle O is 90 degrees? This is a rhombus. In rhombus, the diagonals are perpendicular to each other. Of course, the diagonals also bisect, but for us, perpendicular property is enough. That is why I have taken diagonals are bisect perpendicular to each other. So angle O is 90 degrees. If angle Y is 90 degrees, definitely opposite angle E also will be 90 degrees. Therefore, what we can say, in parallelogram EFGH, angle E is 90 degrees. So, EFGH is a rectangle, children. This is the proof of the third problem. Now, fourth problem, children. They have given a figure in this way. The problem is ABCD is a parallelogram in which E and F are the midpoints of AB and CD. E is the midpoint of AB, F is the midpoint of CD. AB and CD respectively. Show that the line segments AF, this is one AF and CE, trisect the diagonal BD. With this diagonal, it is trisecting. Trisecting means dividing it into three equal parts. This is what we need to prove. So, what is given to us? ABCD is a parallelogram, and E is the midpoint of AB, and F is the midpoint of CD. This is what they have given. And what is RTP? RTP is AF and CE trisect PD. What does this mean? This implies DP is equal to PQ is equal to QB. This is what we need to prove. Now, let us go to the proof. See, we know ABCD is a parallelogram. Therefore, AE is parallel to FC, isn't it? Because AE is a part of AB and FC is a part of CD. AB is a parallelogram. This is given to us. Therefore, AE is parallel to FC, and this is also given. A is parallel to FC is not given. We are saying that AE is parallel to FC, and AE is parallel to FC, and also we can say AE is equal to FC. Why? Because AB is equal to CD. When AB is equal to CD, E is the midpoint of AB, F is the midpoint of CD. We can say AE is equal to FC. Therefore, we will say that AECF is a parallelogram. This is also a parallelogram. If it is a parallelogram, now let us take in triangle CDQ. In triangle CDQ, observe this, children. CDQ, F is the midpoint of CD. This is given to us. And FP is parallel to CQ. FP is parallel to CQ. Why is it? Because AECF is a parallelogram. AECF. AECF is a parallelogram. So, FP is a part of AF, CQ is a part of EF. So, FP is parallel to CQ. Therefore, P is the midpoint of DQ, basing on the theorem. We have got a theorem, children. If a line is drawn through midpoint of one side of a triangle and parallel to another side, bisects the third side. This is what the previous video, in previous video, this proof is there, children. So, P becomes the midpoint of PQ. Therefore, what you can say, DP is equal to PQ. Because P is the midpoint, DP is equal to PQ. So, in the same way, similarly, in triangle, let us take ABP. ABP, we can prove that BQ is equal to QP. BQ is equal to QP or PQ. In this triangle, because these two are parallel lines, this is the midpoint, so a line drawn through midpoint of one side of a triangle parallel to other side bisect the third side. Same proof, so we need not write once again. Basing on this, BQ is equal to PQ, we can say. So this is the first one and this is the second one. So from 1 and 2 we get dp is equal to pq is equal to dp is equal to pq is equal to pq. dp is equal to pq is equal to bq or qb. Therefore, what you can say, af and ce trisect bd. Hence, proved. This is the proof, children. Listen to it once again. They gave ABCD is a parallelogram. E is the midpoint of AB, F is the midpoint of CD, and AF and CE, these line segments, trisect BD. That we have to prove. Trisect means three equal parts it is doing. DP is equal to PQ is equal to QB. You have to prove. So, to prove this, let us see the proof. ABCD is a parallelogram. So, AE is the midpoint. So, AE will be equal to FC and also AE will be parallel to FC. So, AECF is also a parallelogram. If you could prove that AECF is parallelogram, we take now triangle CDQ. In this triangle, F is the midpoint of CD they have given, and FP is parallel to CQ because AEFC is a parallelogram. So, if a line is drawn through midpoint of one side of a triangle parallel to the other side, bisect the third side is the theorem which we have learnt in the previous video. So, basing on that, DP will be equal to PQ. P will be the midpoint, DP will be equal to PQ. Similarly, in triangle ABP also, we can prove that EQ is parallel to AP and E is the midpoint, so Q will be the midpoint of BP. So BQ is equal to PQ. This is also, you can write PQ is equal to BQ. So this is the second equation. This is the first equation that we have got. So because of these two, we can say that DP is equal to PQ is equal to QB or BQ. Anyway, you can write. So this is how we have proved. That means what? AF and CE are trisecting BD. This is the proof, children. Please note it down. With this, I am going to conclude my part today. In the next class, I will be doing the next part.